Hello everyone, today we're going to be going over the 2026 F equals M exam problem 16. This problem is about elastic collisions and relative speeds. So first I want to start off with the joke of the day, the physics joke of the day. A man was recently cooled to absolute zero, but he's okay now. Because absolute zero is like 0 Kelvin. But yeah. Okay. So let's start by reading the problem. A small puck of mass m slides without friction inside a rigid, uniform triangle rack of mass 5m, whose inner boundary is an equilateral triangle ABC. The rack is initially at rest and can move freely on a frictionless horizontal table. All collisions between the puck and the rack are perfectly elastic. At some instant, the puck strikes the midpoint of side AB from inside the rack. Just before this collision, the puck's velocity is parallel to side BC. After the collision at the midpoint of AB, the puck collides with the rack again and then collides once more. At which part of the triangle does a second collision after the initial one occur? Okay. So, let's first, it tells us that after this collision, right, the puck collides with the rack again. So it's going to collide somewhere like here, right? And then collides once more. So it would collide somewhere, well, if we think about it, right, we might think it would collide somewhere on AC. And if we look at all the answer choices, okay, well, this one says the interior of segment AB. This one says BC. And so maybe just based on these answer choices and our reasoning, like on this, we might think that C, D, E are the more likely answers, but and now we have to actually prove it. So first, we know that the rack has a mass of 5m, and this has a mass of m, right? So first of all, we know that the momentum is conserved, right? Because it's perfectly elastic, so momentum is conserved and energy is conserved. But right now, we only need to use momentum. So P is conserved, and we can split this momentum up into momentum in x. Initial equals momentum in x final, and momentum in y. Okay. Yeah. So the change in momentum of y, the sum of momentum of y is going to be equal to 0. Final. Okay. So, first, in the x direction, we know the puck starts with this, right? And in the y direction, the puck starts with this velocity. But then, so when the puck hits this part of the triangular rack, right? We know that the rack will provide an upwards normal force, right? This is the upwards normal force. But since the upward normal force is only in the y direction, it will not provide any x impulse. So no impulse in the x direction, okay? So that means that p of x is going to be constant, okay? And since p of x is going to be constant, that means that this doesn't change, okay? So v of x initial equals v of x final. And now, very importantly, we have to use our properties of an elastic collision, which is the v relative initial is going to be equal to the v relative final and negative. V relative initial is going to be equal to the negative V relative final. In other words, V1 minus V2 is equal to negative, initial is equal to the negative of this. And this is the basically definition of elastic collisions, or like completely, or actually not the definition, but a property, like property, yeah, sorry. But it's basically like the most important property in completely elastic collisions. It's just that the relative velocity swaps. So since the relative velocity swaps, okay, so initially it's going at this, right? The relative velocity is v. Then the final relative velocity would be the opposite direction, since it's now negative, but it's still going to be v. So if we think about this, if we just look at in the frame of the puck, it's always going to be moving in the, so it's always going to be the same x, right? But then it's just the y that flips. So if I draw this path in red, it would look something like this, right? Because the x is the same and the y flips. So this is after the first collision. Now let's think about if we rotate this setup, right? In the second collision, we can view it as the same thing, because it's also a force that's coming this way. So it's going to keep traveling in the new x, but it's going to change directions this way. So the second collision, after the second collision, it's going to go this way. And it always stays at the midpoint, if you notice. So at the end, it's going to reach point D after 2 collisions. So our answer is going to be answer choice E. Okay. Now, thank you for watching. If you have any questions, please leave them in the comments below. And make sure to like and subscribe. Thank you.